All right, welcome. This is mainly for my A4 class. Hopefully you're doing well. I'm sorry I'm not here to help you out today. But if you have any questions, you're welcome to email me, or I'll be back um, Thursday morning, lunch, after school. Remember, I do my tutoring after school Tuesdays, so you're welcome to come then. But I think if you watch this video, this should help you out, okay? I'm going to try and have this so that they can show it on the screen. If not, a lot of you have phones, and you could watch it on your phone. You could share your earpods or whatever, if somebody doesn't have one, although I kind of think that's kind of gross. But anyways, so hopefully this works out. If not, I'll probably just send an email out anyways to just have a link to the website or my YouTube channel, and you could watch this at home. But please be good for your sub. Okay, so here we go. Last time we learned about how to graph circles and all that. Whoa, that's weird. Okay, sorry. Maybe that just didn't look like that, but bleh, I'm all bleh. Okay. It's late, okay? If you look, it's like 11:40, and I'm still getting over with my cold. So I hope you guys are doing better than me. All right, so you've learned how to graph linear equations. Y equals mx plus b. So a quick review for that is if you have an equation and you want to graph, well, first thing you want to do is you want to plot your y-intercept, which is your b, and then you're going to use your slope. Rise over run. Okay. So we'll have some examples of that. Quadratic equations, you're all good with that. If it's in whatever form you want, I think most of your problems will be in standard form like this. So again, if you need to find the vertex, it's negative b over 2a. So that's your axis of symmetry. And then you plug that into your equation. So let me just get rid of that. So once you've figured out this, again, we plug that into our function, and it will give us our the other part for our vertex. Okay. So you may need to review that if you need to. I mean, again, we're going to do some problems with that, and hopefully that will refresh your memory. Okay. And then we're just going to use the 1A, 3A, 5A, the growth pattern. All right, and then circles, we talked about circles last time. If you weren't there, I'm sure there's going to be some time when you'll be able to talk to your neighbor and get caught up. So the equation for circle is x minus h squared or plus y minus k squared equals the radius squared. Okay, so again, r is the radius. Okay, and then h and k is the center. So here would be the center, and the radius here would be 1, 2, 3. So the radius would be 3 in this example. Okay. All right. A system of equation is a set of equations with the same variables. All right. They have the same variables. The solutions of a system of equations are the points of intersection, and are to be written as order pairs, like x comma y. Systems of equation can have no real solutions, like no intersections. So some examples, we could come up with lots of examples. We're just going to cut this into a few examples. Could be something like two parallel lines. That would have no solutions. They won't cross. We could do a quadratic, a parabola, and a line that doesn't cross the parabola. They don't even have to be anyone like that. We could do two parabolas that just don't cross. It could be like that, or you could even have one that's inside, like this. Those wouldn't cross. You could have a circle in a line that doesn't cross, or a circle inside of a circle. I mean, lots of choices where there would be no intersections, okay? So some of those on your homework you may graph and they won't cross, and you just say no, no real solutions, okay? One real solution, we could do something like two linear lines that cross. We could do a parabola and a line like that. I'm sure you can come up with some others. You could do, trying to see if there's any others I can think of. Okay, I guess if you had two parabolas that are like kind of the same, you just got to be careful because, I mean, oftentimes we can't see the end of, the end behavior of the parabola and seeing if they are going to cross. So just be careful. But I'm never going to give you a problem where it would be outside of the graph, so don't have to worry about that. Two real solutions, okay? We can probably come up with more two real solutions. Something like a circle and a circle, a parabola and a line, a parabola and a parabola. And if you can think of some others, then write those down. Infinite solutions would be something like if you had a line and then you had another line on top of that line. Okay, so that has infinite solutions. All right, or you could do a circle on top of a circle, or a parabola on top of a parabola. Those would always have infinite real solutions. Okay? All right, if you ever need to pause, just tell whoever's in charge to pause, and okay, but don't take too much long. You can always watch this again. All right, solve each system of equations by graphing. Sorry, I think I got a little off on when I printed this. These are the steps for doing it. Okay, first you're going to graph each equation. Okay, you know how to do all of them. And second, find the points. Write them as an ordered pair. All right, so nothing is really new today because we've learned how to graph all of these. All you need to do is write down the point where they intersect. So here we have x minus 2. So negative 2 is our y-intercept, so we'll do a point. And then our slope here is 1, so we'll do rise over run, 1 over 1. Something like this. Okay? And then just connect the dots. Please connect the dots. I know some of you guys are like, well, I don't really need to do that. I'm too cool to connect dots. But it does make it look nice. Okay? And then we have another linear equation. So just looking at, we have two linear equations. We know we're going to have one intersect. So here we're going to use blue for this one. So y-intercept here would be 4. And then our slope is negative 1. So we'll go down 1 over 1. Down 1 over 1. As so. Okay. And it goes all the way. Okay. Linear equations, you probably don't need every single point, but unless you're like me and I can't draw a straight line. Okay. Okay, and I want your lines to go all the way to the end of the graph. Okay? And it'd be really nice if you put arrows to show that it keeps going. Alright, you got that? And then all you need to do is say, well, that's our intersection. So we'll write it as an ordered pair. So it would be 3, 1. That's your answer. Okay? But your answer is not going to just be the ordered pair. You need to make sure you graph it too. Alright? Some of you may be tempted to graph those equations on your graphing calculator, and I'm okay with that. You just need to also put it on your homework, okay? On your graph. All right, let's look at our next one. So again, we have another linear equation. Maybe have you pause and try and do this one. Okay, so do the problem, find your x-intercept, and then share it with a neighbor. See if you got the same thing. Okay. Beep. That means to pause. Beep. Okay. So I'm back, and we'll do this. So we have our y-intercept is 4. Slope is a negative 2 over 1. Okay. And then we're just going to connect the dots nicely. Okay. If you don't draw it nicely, then obviously when they intersect, they may not be the right spot, and then you could get your answers wrong. So again, we have a y-intercept of negative 2. Okay, we have the same y-intercepts as our last problem, but now our slopes are different. So now it's negative 1/2. So you go down 1 over 2, down 1 over 2. Okay. And you got it. Okay, so our our intersection would be 4, negative 4. Okay, you good with linear equations? Awesome. Okay, so here we go with C. Looks like we're introducing a quadratic equation. So, again, if you need to refer to the previous page, if you want to come up with the vertex, it's negative b over 2a is our axis of symmetry. So negative b over 2a for us, for this problem, would be negative 2 over 2 times 1. Again, if something's missing for the coefficient, it'll just be 1. So that gives us a negative 1. So we have our axis of symmetry, which is negative 1. You don't need to draw the axis of symmetry, and then the last thing you need to do to find the vertex is to plug that in for your x. So that gives us negative 1 squared plus 2 times negative 1 minus 2. So that gives us 1 minus 2 minus 2, which gives us a negative 3. So our vertex is negative 1, 3. Negative 1, negative 3. Sorry, I didn't say negative last time. Okay? And then we'll use our growth pattern. Since a is 1, we're going to use 1 times a, 3 times a, and 5 times a. So over 1, up 1, over 1, up 3, and over 1, up 5. Okay? It's very important that you put all of those points. Okay, oftentimes the intersection will be at one of those points, so you don't have to worry about like, oh, this intersection is like at some weird point. Okay, and then we'll use a linear equation, so we have our y-intercept, which is negative 2. All right, well that's nice because that already tells us that's our y-intercept, or I mean our intersections, but there's possibly one more. So let's use our growth pattern. So, or not growth, our slope. So we go up 1 over 2, up 1 over 2, and downward as well. Okay, and that gives us a linear equation. And it only crosses at a single spot. So that would be our intersection would be 0, negative 2. Okay? And we could have a graph that went like that, and that would have given us 2 intersections. We could have gotten a line that's like that. It would give us no intersections, or something like this, no intersections. Okay? So there's no guarantee until you graph it to see how many there are. All right. Next one, we have y equals, oh yeah, I'd like you to try and do this one, okay? So again, work on it. get the intersection, share with your neighbor, and then we can unpause. Beep, that means you paused. Okay, here we go. And again, you're welcome to pause anytime if you need to stop. I know it's not nice that I'm not here, but and hopefully this sub can help too. All right, so we have our linear equation. This would be like 3x plus 0, so our y-intercept would be right here. It has a slope of 3, so up 3 over 1, up 3 over 1. Okay, and then we're going to use our quadratic equation, graph our quadratic. So again, you could do negative b over 2a, that gives you negative 4 over 2 times 1, which gives us negative 2. So our axis of symmetry is somewhere on, or is here. You can see that. And then all we need to do is plug that in for our x's. So it would give us negative 2 squared plus 4 times negative 2 minus 2. Gives us 4 minus 8 minus 2. That gives us negative 6. So that's right here. And then we'll use our growth pattern. Again, since a is 1, we'll go over 1, over 1, up 3, over 1, up 5, over 1, up 7, something like that. Okay. And here, like I said, as long as you have your points, you're pretty good, but you also need to be a little more careful with graphing to make sure we understand our intersections. So if you do it kind of sloppy, then it's going to be kind of hard to see. So here, that could be our parabola. Over here, this doesn't matter as much. Okay, so here we have two intersections, and this is the first time we've had two. So we have one that's at 1, 3. And then we have one over here at the vertex, which is negative 2, negative 6. Okay? If you have any questions, ask your neighbor, I guess. Okay? Sorry about this. This should be down here. Okay, so this is another linear equation and a quadratic. I know I'm tempted. I may go back to that at the end. Just want to make sure you have enough time. So here we have some with circles as well. Okay, so here we go. So we have a linear equation and we have a circle. So again, last time we learned how to do circles. Let's do our linear equation first. So here we have this is kind of in a different, it's not written in slope-intercept form. So if you wanted, you could rewrite that as negative x plus 4, if that helps. So here we have our y-intercept, okay? And then our slope would be negative 1 over 1. Okay, and I hope this really works in class for you guys. Okay, connect those dots. Whoop. Okay, and then we'll use our circle equation. So again, our equation for a circle is x minus h squared plus y minus, and that's an h. Someone asked if that was a b. Y minus k squared is equal to the radius squared. So all you really need to do, what we did last time, is we write down what's our center and what's our radius. So our center is our h comma k. Since we don't have an h and a k, it's just 0, 0. And then our radius, this is r squared. So to find r, we just need to take the square root. So the radius would be 4. Okay, so then we will plot the center, and we will plot 4 points for our radius. So we have one right here, we have one right here, one right here, and one right here. And And then you're going to do your best to make a circle. I like to break them into pieces. I feel like I do a little better if I do it that way. Okay. Anyways, so bam, we have our two intersections. We have one at 0, 4 and 4, 0. Those are them. Okay. So I'd like you to try and do H. Again, share with your neighbor when you got it, and then we will come back. So here's my pause sound. Beep. Alright, so we're back. Okay, hopefully you graphed this and you found your two intersections if we have two or one or whatever. Okay, so we do our linear equation. So 7 is our y-intercept. I always get those mixed. Intercept and intersect. You'd think I would be better than that. Okay. Anyways, slope is positive, so rise over run is 1 over 1. Okay. And then we're going to plot our circle. Our center is -3, +2. So remember, what we did is when you take them out, it's going to change its sign because we have this negative and a negative. Okay, so center is -3, 2, which is right here. And then our radius is the square root of 4, which is 2. So we'll do 2, 2, 2, and 2. And then we will do our circle. And you got it. Okay, we have our two intersections. So we have here this time we've got, here we have -3, 4. And then here we've got -5, 2. Alright, so I think that's it. We covered everything. I will go back over these. So if you want to start working on your homework, you can. Here's your homework. Let's look at that. So here we have linear, quadratic, linear, quadratic, linear. Okay, so lots of those. So there's 14 of those where you have to find your intersections. And then just a quick review concerning circles, okay? So you just need to write down the equations. All right. Yes, it is 4 pages or 4 sides. Okay, as you see here at the bottom, x or 4 of 4. But it's only 18 problems, so you can get that done. Hopefully you have time in homework to work on those. And if you have any questions, again, you can come talk to me in the morning or after school. I may even be at the end of school. I probably will be in class after school today. So I'm going to just go back and finish these problems if you'd like. Otherwise, you can just quietly work on your problems, talk to your neighbor. You're welcome to move around if you need to. Just please keep your voices down. Okay, so here we have a linear equation. I'll just rewrite this over here. That's a 4x negative, or 4x plus 10. Okay, anyways. So here we have our y-intercept. So actually that's not a very good spot. Maybe we need to fix this next year, I guess. So we have y-intercept of 10 and a slope of 4. So here we'll have to go down 4. 1, 2, 3, 4, and over 1. Down 4 over 1. Down 4 over 1. Down 4 over 1. Okay, so that's our linear equation. And then we're going to do our quadratic. So -b, -4, over 2 times a, which is -1, gives us 2. And then we will plug that into our equation, so we'll have -2 squared plus 4 times 2 plus 6. So that's -4 plus 8 plus 6. which gives us 10. So our vertex is 2 comma 10. All right, so 2, let me change my color, so 2 comma 10. Yeah, I did not do well for this one, I'm sorry. 2 comma 10. And then our growth pattern is A is -1, so we'll go over 1, down 1, over 1, down 3, over 1, down 5, okay, and over 1, down 7. Okay, so our quadratic is going to look like this. So here's an example where we have no intersections. Okay, that's probably why I put this on here. So we had an example, but then it's not really on the graph. Okay. All right, let's do the next one. If I make any mistakes on these, I'm sorry, and just let everyone else know. Okay. Y equals x squared. Well, that's we've talked about, maybe we haven't. This is called the parent graph. So it's every parabola is based off of y equals x squared. Okay. And if we did do one more point, it would be outside of the graph. Okay. So here, I mean, if you wanted to use negative b over 2a, well, b is 0. 2 times a. And then you'd plug that in for x, and 0 squared is 0, so our vertex is 0, 0. Okay, and then we'll do our other quadratic. So negative b over 2a, again, b is 0. And when you plug 0 back into our equation, we'll end up getting y is equal to 8. So here our vertex is 0, 8. Sorry. 0, 8, which is right here. And then we have our growth pattern of a is -1, so we'll go over 1, down 1, over 1, down 3, over 1, down 5, and that's probably enough. All right, so we have 2 intersections. One is 2, 4, and the other is -2, 4. Okay? All right. Well, good luck, and again, let me know if you have any questions. See ya.